morning, everyone. I really appreciate you coming here, joining my talk. I think you made the right choice. Yeah, so we'll be talking about ASGI, ASGI. You can see my title, the engine behind modern Python web frameworks, but we'll go a bit details. So here I am. I'm Rafiqul Hassan. I'm working as a senior lead engineer at Bikash Limited. We are the largest financial platform in Bangladesh, serving millions of users daily. So, so here's our agenda. So it may look like a lot, but bear with me. We'll go through there together. So we'll start from what is ASGI, the specification protocol, and all the details about the protocol itself and how it connects to the Python event loop and what implements the server, middleware, and the frameworks, and what's ahead in our future. So let's start with the beginning. So not just the ASGI, what came before it. So we have like web server gateway interface. It was introduced in PEP 3333, but in 2003. So it was a synchronous protocol, but if you may already heard it about if you already use Django or Flask. So Django and Flask, those are like based on web server gateway interface, WSGI, and it was like defined as a synchronous and single callable interface. So you can see the WSGI contract here. It was as simple as that. It has like you have like one callable application. So and you had environment, a dictionary, and a start response, a callable. So it was perfect, like in that era, like 2003, or because at that time we had like nothing much to do on the web, so we just queried some data and render some HTML, and that's it. And the environment dictionary is a dictionary of like HTTP metadata, headers, and methods. And start response you call to send status and headers first, and then return iterable of bytes string. So that was it, the WSGI contract. So what the problem was, like the WSGI server, it handles one request at a time with one thread. If you wanted like handle more requests, you use something like a GDCon server that runs multiple workers. But multiple workers means multiple processes in operating system. So even like one worker can handle one request at a time. So it was not like that kind of scalable. So the main problem was that like in 1999, Dan Kegel published a paper called the C10K problem. So he asked a simple question. Can a web server handle 10,000 concurrent requests at a time? But think about that. At that time, most of the server couldn't handle that because one request, one thread per model. Because if you think about a thread takes 1 to 8 megabyte of stack memory. So if you want to handle 10,000 simultaneous connection, then you have to spawn 10,000 threads. So that means like around like 80 gigabytes of memory. So that was like very expensive. So he asked the question, and operating system like was handling this with IO multiplexing, because in POSIX or like in Linux we had like EPOL, and in BDS or macOS we had like KQ, and Windows we had like IOCP. It was like even notification system. So borrowing this concept, so what we have now is something called event loop. So now you don't handle every request in a single separate thread. So you have a single thread handling, running the event loop, and we are using the file descriptors from operating system, the event notification system. So we just listen to this event notification, and when an I/O calls happens, and then operating system notifies us that something is ready or something you need to do about this event. So we can see that thread model, we can, if we have to like handle 3 requests in 3 separate model, but in event loop, you can see like one single thread can handle like multiple requests. So the mental model shift was like this. Before, you can think like Python didn't have like this kind of uh, the asynchronous mechanism before 3.4. So async IO introduced in 3.4, and then the keyword async await introduced in 3.5. And then we had like a mechanism like await. So here you can see that before we had like synchronous and blocking call with, like, say, if you do the DB query, so the thread sleeps here, the thread gets blocked. And when it happens, the CPU is free, but thread is not. Thread is parked here. But in async, when you use the keyword await, and the DB, the thread tells that operating system that here is something I want, an IO operation I want you to do and notify me when it's ready. So it's just running an event loop. It just hands off this IO operation like DB query to the operating system, and then the event loop goes to the next task on its ready queue. So this is the main mechanism for our secret of like handling thousands of connection at a single thread. So we had like already this mechanism of like event loop and async await. So, but we needed something, specification or protocol, but a mechanism to like to baked into this Python ecosystem, like we can so that we can handle multiple thousands of connection at simultaneous connection in a single thread. So the ASGI was born. So it was like ASGI is like asynchronous server gateway interface. So back in like 2016, the Andrew Godwin, he wanted to add WebSocket support to the Django. So, but there's like no way WSGI could handle this kind of mechanism. So he proposed a specification called ASGI, and this specification then formalized as separately. It escapes from Django project itself. So I want to like I want to like take this a moment. Like ASGI is not a library, it's not a framework, or it's not an implementation itself. It's just a document. So it says if a client or a framework or a server talks this language, they can work together. So ASGI is just a contact, a shared language. So, and what defines ASGI is, so what's our, sorry, excuse me. So why we need our interface? Because, or a specification. Because you can see if you don't have a formalized interface, so what happens, like any ASGI or like any web framework have to have like their own server to support their framework, or like not every framework will support like not every server will support every framework. So we needed something formalized. So they formalized it so that like you can use your ASGI app, like it can be any ASGI app like Starlet or Fast API, or even like raw ASGI, just your simple Python code. But you can run it with like any server currently now, UVcorn, Hypercorn, or Daphne. That's the power of like a shared specification. So they don't like say, they don't have to like know each other or share each other codes. So this is our simple ASGI specs. So it have a like callable signature app. So it has like 3 arguments: scope, receive, and send. And it defines the shape of the scopes And also the receive and sends are the awaitable. So it has like all the events coming from client to server. Its incoming events is you all the consumed by receive, and you push your outgoing events to the client via send. So let's look at the contract itself. So you can see this, the ASGI defines this contract, like this is ASGI contract, that's it, a simple app. So it has like scope, a dictionary, and receive, an awaitable, send, another awaitable. So scope is a dictionary that like has all the metadata, like who connected from where and what's the protocol itself, like HTTP or WebSocket, anything. And you receive all the data from client via receive. And you send all the data from your server to client via send. So this is it, as simple as that. You can run this like function with any compliant ASGI server like UVCon, and it will just work. So this is a simple ASGI app. You can see like it's an we can consume the request body from the receive, and we can send the response with send. So send awaitable. So you can like send all the responses here, and you can run this app with UVCon, and it will just work. And so let's start with scope object first, because it has all the connection metadata and protocol abstraction. So it's doing more work than we realize. So what is scope? It's a just plain dictionary. It describes everything about the connection, and it's immutable. So you just read it, you don't modify it. The server parses all the connection metadata and client metadata from the TCP connection itself and hands over to you. And you don't modify it. You just take decision based on all the metadata, or you just consume all the metadata. So the type keyword is the single most important field. So it defines the protocol itself. Like, is it HTTP, or is it WebSocket, or is it lifespan? And we'll go about talk about this a little bit later. So let's see about the HTTP scope. So first we have like protocol identity, which protocol it is, version, and the type, and we can see the method and path and query string of the HTTP request, and we can also see the headers and about network things, clients and server, all the things you see in this scope itself. And you can say another thing, interesting thing is that the WebSocket scope, it almost looks like the same as HTTP scope, but the type is just different. That's because a WebSocket request starts with an HTTP request with an upgrade header, upgrade WebSocket header. So the server, once they see an upgrade WebSocket header, so it knows that it's not an HTTP connection, it's an WebSocket connection. So they can like keep the connection open for a very long time. And the lifespan scope is the simple one. It has nothing, just it says the type is lifespan, that's it. All things happens in the event itself, like in receive event and send event. So let's talk about the event stream. So most of us may think that an HTTP request, when we serve the HTTP request, is just a function call. We just call a function, then we returns the value to the client. ASGI says no, HTTP is a conversation. It's not just a function call. So you can convert, because it's supposed streaming. A client can send multiple data in a single connection. So you need to handle that. So the core idea is ASGI doesn't model HTTP as a just request and response model. No, it's a stream of events. So we can like consume all the data, streaming data from receive, and we can send all streaming data via send keyword. So yeah, so this is our all incoming events. So you can see in HTTP events, so there's like HTTP request. So we have body here with more body keyword. So if it's true, then we run a loop and consume all the body data. But if the more body is false, then we know that no more body is coming, and this the request ends here. And HTTP disconnect is another event. It says like client is gone, the client got disconnected, or they lost their internet connection or something. Because if you have like any heavy CPU operations or like large database call, so you don't want to waste resources if the client is disconnected. So you can handle that with this event. And we have like WebSocket, connect, receive, and disconnect events. We have lifespan events. So the lifespan events, it just tell the app that the app the server is like started or the server is shut down, because you can handle multiple things, that initial database connection, or like you can on a startup, or you can like clean up all the things in shutdown events. So those are like our incoming events, and these are like outgoing events. So we have like HTTP events, we response body start, we send status and headers, and this is always comes first. And then we start to send body in a loop with a more body keyword. And WebSocket events sends, we accept the connection and send or close the connection. So here it is. So you can see we have an application and we have one inbox and one outbox. We with the receive events, we consume all the incoming data or request and everything, and with send, we send out all our outgoing requests and connections. So we talked about app a lot. So, but we may think, so who owns the event loop? Who runs the event loop? Who handles all these things? All the concurrency, all the event handling. So the server implements it. So we seen the app's perfect. So now the ASGI server owns the actual event loop. The application is a guest running it, because when you run your application with uvicorn, like uvicorn.run, then uvicorn itself runs and manages the event loop, not your application, not your fast API app, not your Starlet app. It's uvicorn itself handling all the things. So we have like 4 layers. Can you see the diagrams here? I'm not sure, but we have like 4 layers of things. So first layer is the operating system layer, because the operating system layer, you can see here, so it reads the TCP sockets. It doesn't know about any HTTP or anything. It just knows that we have some data on some sockets. That's it. And EPOL and KQ, that handles the event loop and listens to the EPOL or KQ, waits, then notify the event loop that we have some data in these file descriptors, and then event loop handles all the connections, like it reads the raw data from the file descriptors and schedule coroutines and everything in its queue. But the server itself do the connection handling, like protocol parsing and everything. Is it a HTTP protocol? Is it a WebSocket protocol? And that's the things the server handles. And then when it parses the protocols, and then it creates a task with your app. This is the moment your app starts just now, when your handler is being called. So this will be the most technical one inside the server. Server handles a lot of things for us. So let's see. So main, server handles a lot of things before your app even called. So, but it has like 3 main responsibilities. So it has like, it handles the transport, it handles the protocol parsing, and it handles the back pressure. So back pressure, we'll go a little bit more about the back pressure, because it's very interesting. Because, you know, if you like want to send just data, but the client cannot handle all the data because the client is slow, then what happens? So the back pressure will handled by server, that if client is slow, you can't send the data. So it slows down. And if the server is slow and client is fast, then it handles also the opposite back pressure as well. So the client's TCP connection, so what a server does. So servers, our async has a mechanism and transport, our protocol and the transport class. It handles all the protocol and connection things. And our server, especially UVCon, uses H11 for HTTP 1.1 to parse all the connection metadata and packed into the ASGI protocol itself, like do the scope, build the scope, and body receive all the body in the request queue, and create, calls your app. And when your app sends your data, then the ASGI server itself sends it to queue, and then from the queue, it serializes the data to bytes, and then we have the operating system has send buffer, so that the server sends the data to the send buffer. If client is slow, the send buffer is full, then say the queue notifies us that no, you cannot send more data here, so we have to slow down a bit. So, and then the operating system flushes all the data to clients from that send buffer. So the most amazing part of this ASGI specification is their middleware design. So the middleware is just a callable, a function that wraps another function. That's it, nothing else, no magic. So we can wrap, because receive and send events, those are already callable, we can wrap this with another callable like log receipt. If you want to log all the data, so we can do this, and this await app, we can pass this wrapped, our wrapped function, like logged receive and logged send. Then you can, that's it. This will just work. And because middleware can intercept from incoming connection to outgoing connection all the way. So you can even short circuit it. You don't have to in here we call the app with their respective wrapped callable, but here we didn't call the app. It is because if the client is user is not authenticated, why we need to call the app itself. So yes, and the middleware stack is if you want to stack multiple middleware, it just you just compose functions. You just function composition. So let's you can see auth middleware and the login middleware, and we call the actual inner app our app itself, and it flows from server to from incoming connection. It checks the middleware auth first, and then the log middleware. And on the outgoing side, it just reverses. We call the logging middleware first, and then the auth middleware. So what does frameworks do? Frameworks is not on top of ASGI protocol. It implements the protocol itself. It just gives you some abstraction like request object, response object, and everything. It just makes a more developer experience, so that you don't have to write all these things for yourself. So it just, you can see, this is a valid starlet implementation of the contract. All this fast API or starlet is just implement this protocol, app, scope, event, receive, send. That's it. Under the hood, everything is reduces to this function, this contract. That's it. And they just add some abstraction on top of that. So supports, they have middleware stacks, lifespan handlers, and background tasks, and everything. So with that, we can build our web application more easily. So here is our FastAPI life cycle. What FastAPI handles a few things more, like it has a dependency injection and pydantic validation, and all the route handling and response serialization. Uh, so what's the future? So let's see the evolution timeline. So the ASGI protocol, the specification itself is stable and it's battle tested already, but the web is not like stand still. That we had like problem with WSGI, so that ASGI don't have a problem, so that we don't have a problem with ASGI. So they designed this way. So that we have a support for extension. So if you want to like add support for like more protocols or more mechanism, we can add extension. And if we want more like capabilities like add to support more protocol, we can add type, new type like MQTT or like HTTP3 and anything. We can add support with this extensibility. So thank you. Sorry, I had to like finish a little bit fast in the later side because I don't have much time. So thank you. And if you have any question, I'm happy to answer.
Hi.
Hey.
So yeah, I have a question though.
Mhm.
So you mentioned that ASGI is
Mhm.
purely a standard,
Started,
right?
yes.
Yeah, standard. And I noticed that it's more implemented in Python framework. So was
Yes.
there any attempts to implement ASGI outside Python?
You can implement it outside Python.
Outside
Yes,
Python itself?
yes. It is just a specification. It's not Python specific. You can implement it. But the thing is, it's more focused on the Python itself uh, because of the like everything, the event stream and everything. But if you have like another language that supports this event loop kind of things like Node.js, you can absolutely do that.
But was there any existing framework you
No,
know?
not yet. I don't think so.
Thank you so much.
Hello, I am Ben Spock, and you mentioned that ASGI empowers for better debugging.
Mhm.
And I am just curious to know
Mhm.
what are your go-to tools or like strategies for like tracing a request through like complex like ASGI stacks?
Okay, so you can like to debug better for a complex thing. So what we do, we mostly have a very detailed middleware. So we intercept everything in the middleware. As you saw, as I showed you, like the middleware is function composition. So we can intercept like everything your app sees or flows through in the middleware. If you like, you can do one thing. If you print all the data, scope or like everything, and build a middleware itself and consume all the data and see that all the things you can see happening your app, you can see before or after in the middleware itself. So yes, you can like do more logging or do like more tracing in the middleware itself.
So, sorry. So essentially, like the middleware acts like the more like I guess functions in the middleware stack is I can think of it like as like a little filter as your
Yes, you can do the filtering things, and you can handle like more tracing and logging and things and everything. Uh, It, it's like it's flexible. You can do so much more in the middleware.
Thank you.
Yeah.
Hi, thank you for
Yeah.
the talk. Seems like ASGI is like a total upgrade to WSGI.
Yes.
Like, is there any like cons to ASGI? Like, for example, if you tested it on an app from a pure WSGI to ASGI, like is it always like 100% better? Like, I'm saying like ASGI is so good when I
Yes.
hear it, but did you encounter like any cons to it?
So actually, the ASGI is just a specification, and I do not see yet a cons for ASGI because it has one thing that in the last few slides I show you, the extensibility. So you can extend, add new protocol by yourself. It doesn't have to be the specified HTTP WebSocket protocol. You can add your own protocol. You can add your own MQTT or your own HTTP3 and anything. Any protocol you can add, just type and extends with an extensions dictionary. You can specify your own protocol as well.
That's it for our Q&A.
Thank you
so
everyone
much,
for having me.